Assalamu alaikum. It's me, your teacher, Ms. Faradiba from Peshawar Model School, Nashara branch. Today we will talk about the chemical equilibrium of chapter number 9, class 10 chemistry. In this chapter, first we will talk about the introduction or definition of chemical equilibrium. But before going to discuss our topic, I would like you to subscribe our channel so you will watch our videos continuously. Okay, let's come to our topic. What is chemical equilibrium? Before going to discuss this topic, we would like to discuss the chemical reaction. What is chemical reaction? As we all know very well about the chemical reaction, or we learned a lot about the chemical reaction in our class 9, but we should have to revise some of our knowledge about the chemical reaction. That what is chemical reaction? Chemical reaction simply means when the reaction occurs when two or more molecules interact and the molecule change, or the process in which one or more substances, the reactants, are converted to one or more different substances or the products, are called chemical reaction. Here is the example of chemical reaction. A chemical reaction is being displayed by an equation. This is the simplest equation. When A and B, these are two reactants which are on the left side of the arrow. When these react together, these will form products C and D, which are on the right side of the arrow. Here A and B react to C and D in a chemical reaction. Here is a common example of chemical reaction. This is what we can call the combustion reaction, when carbon is react together with oxygen, and this will form the carbon dioxide gas. This is the most common example of chemical reaction. Okay, let's come back to our definition of chemical equilibrium. The state of chemical reaction when the concentration of reactants and products are unchanged over all time is called chemical equilibrium. Okay, now what does it mean by the term concentration? Concentration simply means the amount or the substance which are reacting together and form new products. So it simply means the measure of a amount of a chemical species in a particular of a solute in a solution in terms of amount of substance per unit volume of a solution. For example, we are making the salt solution or sugar solution. So for that we will take some salt or sugar and mix them in water. So after that we will get that salt or sugar solution. So let's suppose we are taking the 1 teaspoon of salt or sugar and mixing them in a 1 glass of water. So that 1 teaspoon of salt or sugar is the concentration of solute in that solution. Okay, the state of chemical reaction when the concentration of products and reactants are unchanged over all time is called chemical equilibrium. Unchanged over all time means that it is necessary that a chemical equilibrium reaction, there must be some stages came when the amount or the concentration of reactants and products must be equal in their quantities, or we can say the forward and backward reactions will be equal to one another. So after that we will attain the chemical equilibrium, or we can say the point at which the opposing processes becomes equal in rate is called chemical equilibrium. Opposing processes means opposite processes, and it means that forward and backward reactions will be equal and the rate is called chemical equilibrium. We will discuss the forward and backward reaction in detail in our chapter, but for your convenience we will talk about the um, rate of reaction. That what is rate of reaction? Rate of reaction simply means the speed of the speed at which the chemical reaction proceed. It is often expressed in terms of either the concentration of product that is formed in a unit of time or the concentration of reactant that is consumed in a unit of time. It means that how much reactants are react together and form how much product in a chemical reaction. So that amount of substances are called the rate of reaction, or we can say the speed at which the reaction proceed are called the rate of reaction. Okay, now let's come to the explanation of our so much easy topic, the introduction of chemical equilibrium. Let's watch this diagram. In this beaker we take some water, and by keeping this water at constant temperature, this is the open system. Open system means that we will not cover this beaker by any coverage. Okay, so we will, when we start heating, some of the water evaporate in the vapor phase, but after that very little amount of vapors become condensed back to the bottom of the container, because there is no cover at all at this beaker. But if we look at this beaker, this is the closed system. Closed system means that we will cover this system by some cover. So by keeping this water at constant temperature, at the start water begins to evaporate. And when this process begins, at some stages these vapors become condensed back to the container. And although at the starting point, or at the start, the amount of evaporation, or we can say the rate of evaporation must be higher than the rate of condensation. But after some time, the rate of evaporation becomes equal to the rate of condensation, and that point is what we can call the chemical equilibrium, when the mm, amount of evaporation or condensation are equal in one another. This arrow shows the evaporation, and this arrow shows the condensation. Okay, now do you know about the evaporation or condensation? Uh, Although these are simplest phenomena, but for your convenience, I will show you this. I will show you their definitions. The process of a substance in a liquid state changing to a gaseous state due to an increase in temperature is called the evaporation. Now let's example of see the example of evaporation. What is the example of evaporation? Forming of water into steam by giving temperature is one of the example of evaporation. Look at this reaction. When we keep this water at constant temperature, it will convert it to gaseous state, or we can say the vapor phase. Now look at the condensation. The process by which water vapors in the air is changed into liquid water is called condensation. Now look at this reaction. This is the backward reaction of evaporation, and when these vapors become condensed, and it will convert into liquid water. In our daily life, the dew drops which are formed on the grasses in the morning is the common example of the condensation. Okay, now look at this common reaction, or the chemical equilibrium reaction. When we give temperature to this water, it will evaporate, and the upper one is the forward reaction. This is the evaporation, and when these vapor phase condense back, it will convert into the liquid phase. The double arrow shows the equilibrium state. It means by keeping the temperature constant, the concentration of water and vapor become constant and does not change with time. Many reactions proceed to certain extent and then stop. The reactants are not consumed completely. Instead, we obtain an equilibrium mixture containing both the reactants and products. When a reaction reaches this stage, it is said to have an equilibrium. What does it mean by this? At some time in the reaction mixture, the reaction stop. It doesn't mean that our reactants are finished or we consumed too much reactants. It means that there must be established a chemical equilibrium by which stage the reactant and product amounts are same. So that stage is called the chemical equilibrium. Historical background. Here is the short historical background of chemical equilibrium at your level. The term chemical equilibrium was first introduced by the chemist Berthollet in 1803.